Okay, so there it is. Okay, so here's literally question number 1 that you'll get in your homework. All right, so they're basically giving us a section of the number line there between, what is it, between 3 and, can you all see that? It goes between 3 and 6. And they're wanting me to express it as an inequality. Like they want like x greater than 3 or x less than 6 or greater than or equal to, or they want something like that. I'll get to the particulars in a minute. Something like that. They want some kind of a statement with x and greater than, less than, involving the 3 and the 6. Well, how do you do that? Well, what it is, it's all about the x represents the shading. Whatever you say about x, you're saying about the shading. So what is the shading? Well, the shading is between 3 and 6, isn't it? The shading is between 3 and 6. So therefore, put the x between 3 and 6. So this is how we make the statement, not like these. But we put the x between the 3 and the 6. Now, which way do the symbols go? How do you logically, correctly say that the x is between, the shading is between, the x is the shading, the x is between 3 and 6, like greater than, less than, which way do the symbols go?
Less than or equal to.
Less than or equal to for both?
Yeah.
Correct. For both. Do you all know that? Why? Well, easy way to think about it, it's like ordering a soda or something, small, medium, and large. Right? The left side is the smallest one. The smallest is smaller than, right, less than, the medium, and the medium is smaller than, less than, or equal to the large. Right? Isn't that true? The 3 is smaller than the shading. It's left of the shading, and the shading is left of the 6, smaller than the 6. So the x, the shading, is between. That's correct, isn't it? Logically, that's right. Now, why do we have that? Why don't we put it like this? Why do we have the equals bar? This is the bottom of an equal sign, right? You know, an equal sign like that. That's the bottom of an equal sign. Why do we, you know that means less than or equal to instead of just less than. Why, though? Why do we say less than or equal to instead of just less than?
It means it's not that number.
Right, good. So first off, it means less than or equal to 6, greater than or equal to 3. So meaning it can be 3 right on the money. It can be 6 right on the money. Not just 5.9999, but it can be 6 right on. It can be 3. It can be equal, or it can be greater, right? Why, though? Why do I do that? What does it have to do with the symbols here? Do you guys know brackets mean right on the money? So let me write that. So when you have brackets, you use greater than or equal to. If you have parentheses, you don't have the equals bar. Because the bracket here, bracket means right on the number, whereas the parenthesis means, whoops, kind of getting scribbly there. Parenthesis means close to the number, not right on the number. Are you aware of that difference? So parentheses are rounded, aren't they? They mean you're around that number. You're close to that number. But the bracket has a straight edge to it, right? Straight edge to the bracket. So that means you're straight on that number. So they're saying you're straight on the 3, straight on the 6. That's why we have the equals. If they put parentheses on both these, then I would take off these equals bars. Makes sense on all that? Questions on that? So there's problem number 1. You'd actually type in, yeah, on the math. Yeah, I'll show you. I'll enter one here in a minute. Here, let's do this one. So again, there's the shading. And remember, the shading is the x. So what is the shading? What is the x? This looks like what? -1 here? That spot. And how far does it go to the right? 12?
No, it goes beyond.
Yeah, can everybody see? I don't know if you can see that arrow all the way in the back, but there's an arrow there, which means it goes forever to the right. And how do you say forever in math?
Infinity.
Yeah, the sideways A, because that symbol just kind of keeps going and going, the eternity symbol, the forever symbol, right? So that means the x is between -1 and infinity. Now, we don't write it like this, though. We don't put a -1 and an infinity. Well, actually, yeah, they want me to go So having said that, we don't if we're doing greater than, less than, but notice what they want me to do. They want me to go to interval notation, which is another way of notating it, probably an easier way, actually. And all you do for interval notation, right, that, is just do left edge, right edge. Interval notation means left, comma, right. So what's the left edge? -1. What's the right edge? Infinity. Now, how do I know if I put parentheses or brackets? Well, you just do whatever they had. What did they have on the left edge there? Bracket. So I put a bracket on the left edge. You just follow whatever they had. Now, on the right edge, they went forever to the right. That's because I have infinity. They have an arrow. So we have forever to the right, infinity. So what do you think you put? What would make sense? Would it make sense to put a bracket next to infinity? What does bracket mean? Straight on. Can you get straight on infinity?
No.
You might go to the doctor's office and say, I waited forever. Well, you didn't really wait forever. You just got close to forever. Yeah, right. So it's a parenthesis, huh? We always put parentheses next to infinity. You never put a bracket next to infinity because you can never be right on infinity.
Anything
Always a
so
parenthesis.
specific to find number.
So we would just choose the option there. Which one is that? It's B, isn't it B?
Looks like B.
Yeah, B. B it is on that. That good? You have infinite tries on the homework. If you get one wrong, you can guess again. You have infinite tries. Once you get it right, 100% right. So you can get 100% on your homework. You just keep guessing. After 2 or 3 guesses, depending on the type of problem, it'll say wrong. You know, you're out. 3 strikes, you're out. But then a button will appear down below which says make a new one, or was it a similar exercise. And you just click on that. It changes the numbers. You have 3 more tries. And you just keep going and going. Once you get it right, it's 100% right. So you can get 100% on the homework, just about doing it enough times, if you're one of every type of your homework question. All right, so this one is basically, I don't know if you can read it all, let me make it bigger. It's saying that, and then it's saying change to interval notation. So basically, I don't know if you're catching on, but there's 3 ways to speak of 3 languages in math, 3 languages that we speak of a section of numbers. We can do it with inequalities. That's the inequalities. We can do it with intervals like those, parentheses, brackets, 2 numbers. And you can also do it on the number line. There's 3 ways of indicating a section, a group of numbers. So they want me to go from inequality to interval. So that means like 2 parentheses, or maybe a bracket and parenthesis, comma, 2 numbers, left number, right number. So the left number is 5, the right number is 9. Now, how do I know if I use parentheses or brackets, though? What am I going to do? This has the equals bar, so bracket. This does not, so parenthesis. Good? That's all there is to that. Left edge, right edge. So the bracket is for the equals, right? Because you're straight on the 5, you're equal to the 5. But you're only you're only less than the 9. You're not right on the 9. You're 8.999, but not 9 right on the money. So you're just close to the 9. All right. Okay, so it says x greater than -6. Can you write that? Let me give you a second. Write that as an inequality. I'm sorry, it is inequality. Write that as interval notation. Which means, 2 numbers, the left edge, the right edge. It might help, they also want us, they're going to make us go to the number line also. It might help to do the number line first. Could you put this on a number line?
Mm-hmm.
So we just have -6. Is it going to be a parenthesis or a bracket? It's going to be a parenthesis, huh? Because there's no equals bar there. It's just greater. Everybody tracking with me on that? It's parenthesis, and the shading is to the right. The x is to the right, not to the left. How do I know? Because x is greater. Greater numbers are to the right, aren't they? This is where the positive numbers go, to the right, the greater numbers. The lesser numbers go to the left. So when something's greater, it goes to the right. And it's parenthesis because there's no equals bar. Right? Now, it's easy to go from the number line answer to the interval notation answer. So the left edge is -6. What's the right edge? It's infinity, huh? Both get parentheses, don't they? We always put a parenthesis next to infinity. So there we go. Is that good? Questions on that one? All right. You can do homework late, by the way. It's half credit. Anything done late. So this section is due Thursday at 9 a.m. Not 9 a.m. Yeah, 9 a.m. Thursday at 9 a.m. And but if you do it late, it's half credit for the ones you do late. So in other words, the assignment is due at class time. So say you do 50% of it on time by 9 a.m. You'll get that. I'll never touch that. That's yours. That's good. 50%. Suppose you do the last 50% late. Well, then I'll give you half of that last 50%. You'll actually get 25% of that 50%. So in the end, you'll have the original 50 and 25 of the other 50, 75% on the assignment. Does that make sense on that? That'll actually happen at the end of the semester. I won't touch it for now. Math Excel will tell you you got 100%, but it marks it red on my teacher screen telling me you did that last 50% late. End of the semester, I'll click a button where Math Excel goes back and grabs all the late stuff and makes it half credit. So that'll happen at the end. Is how that works.
Number 8.
So we have 6, 8. So they want you to write an interval. Oh, no, inequality. They want you to write an inequality, meaning, x greater than, less than. See if you can do that. Turn that interval notation into an inequality. Give you a second. How we doing? Did you get that? Is that good? Because the x, the shading is between 6 and 8, right? This means all the numbers from 6 to 8, doesn't it? And brackets mean we have the equals bar because you can be right on the 6, right on the 8 for the brackets. Good. Stop me if you want to talk about it. If I'm going too far. Negative infinity, comma 1. Yeah, so change that to inequality. And they want number line also.
Okay.
So turn that into inequality and number line. Give that a try. All right, so how do we do that? I'm going to maybe go to the number line first. On the number line, remember this is left edge, right edge. So the left edge is negative infinity, left forever. The right edge is 1. So the shading is right there, isn't it? It's all the numbers from negative infinity to 1. Left edge, right edge. Interval notation always means left edge, right edge. Left edge, right edge. Negative infinity to 1. And this is the x right here. This is where the shading is right there. So now how do I write an inequality statement? Well, that means x is what? How do I write it? Less than 1. Yeah, you don't put the infinity down, the negative infinity down on an inequality. You just say x is less than 1. Because the shading is all the stuff left of 1. Less than 1. Does that make sense? On that, we good? Any questions? Please feel free to speak up. You're probably usually other people have the same questions, helpful to all. All right. So 2x minus 6 greater than 4. So go ahead and solve that real quick, like you would in algebra. Inequality. All right, so what do I do to solve that thing? Add 6 to both sides. So I get 2x is greater than 10, like that. And then divide by 2. And so x is greater than 5. We good there? Remember all that algebra stuff? What do they want? They want, type your answer in interval. Yeah. Notice the blue line. They'll tell you how they want the answer. Interval notation. Okay, so how do I, so I can't stop here. That's not interval. Interval means like the two numbers, left edge, right edge, you know, kind of thing. So that's how they want the answer. They want interval notation. So how do I turn this into interval notation? Greater than 5? 5 to infinity. We okay with that? If it's confusing for you, you could do the number line in between to help. It means from 5 to infinity, x. So x is greater than 5, means from 5 to infinity. So this is the answer they want, 5 to infinity. Does that make sense on that? We good with that? Math 4B? Here we go. So there we go. Questions? Can I flash off that? You okay on that? So this is what they want. Okay, so minus 2 parentheses 3x minus 4 greater than 2. Can you solve that? Try that one. So start by distributing that minus 2 probably. Be a good idea. You could divide by it, but probably distributing might be a little easier. That's multiple choice on this one. Are we ready? We doing good? Distribute that through like that. Minus 6x plus 8. We good? And what do we do next to solve for x there? Okay, subtract that 8. Like that. So bring down the minus 6 greater than minus 6. Next step?
Divide by negative 6.
Divide by negative 6.
Makes it where it flips the
Good. Do you guys remember that? Got to turn that symbol. Yeah. So when
divide by negative.
you multiply or divide by negative, flip the symbol. Yeah, you gotta flip that symbol. So right there and then flip that symbol. So x is less than, and that's just 1 over there, isn't it? Negative 6 over negative 6 is 1. X is less than 1. So what's the answer? Choose the answer below that the solution set to inequality. Oh, I keep looking and saying, why are there two answers? It's A. They're just giving the answer in both inequality. I don't know if that's confusing for you. They just put a set thing and an X and a straight line. See, there it is right there. Don't let that throw you off. That's just called set builder notation. Don't worry about it all. This just means the set of all X such that that straight line is actually math shortcut for a word. Anyway, don't worry about it. Just focus on this part. Go, hey, look, it says X less than 1, X less than 1. That's my baby. Grab that one. That's good enough. Don't worry. That's just called set builder notation. It means the set of all X such that X is less than 1. All numbers that are less than 1. That's all that means. And then they put it in interval notation as well. So, whatever. We just had to grab the multiple choice answer there. Is that okay on that? Questions on that? Basically, when you got fractions in there, it's best to just try to get rid of them right away. Just multiply through. So we got 1/6 parentheses x minus 10 less than x plus 15. Yeah, what I would do, I mean, of course you could distribute, but that would be a pain. It would be a pain to distribute that, and then you got a couple fractions and all that. What would be best, what would be quickest and easiest, is just to get rid of the fractions right now. So just and what's going to do that is multiply through by the common denominator. So multiply through by 6, that's a 6 there, 6 here, and 6 there. Now, a good question you might have is, hey, Mr. Aaron, why did you put the 6 only on, why didn't you put it on the x and the 10? Well, whenever you have parentheses, whatever you do to the front item will eventually distribute to all the items inside. So you really, by doing it to the front only, you really have done it to everything in the parentheses. Does that make sense? So you just do it to the front. And what will it do? It'll cancel that front out. That's why I'm doing it, because I want to get rid of the fractions. And so all we'll have left is the 1. The 1 will distribute. 1 times x is just x, and 1 times 10 is just 10. Nothing really happens. 1 doesn't change anything when it multiplies. The other side, it's 6x plus, that's 90, right? Does everybody see what happened there? So I multiplied both sides by the 6. I multiplied both sides by the 6. Good, and we got rid of the fractions. That's pretty much what I try to do whenever I've got fractions. Just get rid of them on that first step. Just get them out of there. Now it's easier. There's no more fractions. Now, it's still not simple though. It's still a little bit of work. What should I do next? I have here's the wall if you want. Separator. I got x's. You should do something about these x's first. When you have x's on opposite sides, you really want to do something about those first. What should I do about x's on opposite sides?
Can you subtract the x from one side?
Yeah, get rid of one of them. It really doesn't matter which one. Good idea. I'll just go minus x on both sides. Yeah, like that. Or you could do minus 6x and get rid of that one. It doesn't matter. Just get rid of somebody because you don't want two of them. Do that first. Don't do the minus 10 and the 90. Do them later. First, deal with the x's. You know, when you have those on opposite sides, you got to get rid of one of them. Okay. 6x minus x is 5x. Good so far? Now we go back to the normal work of getting x alone. So subtract the 90. We get here minus 100. 5x. Last step to solve this. Divide both sides by 5. And what do we got? Minus 20. We have it like that, don't we? I just brought this over here. Everybody see what I'm doing? So I don't know if you can see it with the watermark, the Doceri watermark here. I divided both sides by 5. Minus 100 over 5 made the minus 20. Everybody see? Now, this is on a test. That's fine. I'll give you full credit for that answer. That's a good answer. To be able to grab the right multiple choice, it might help you to turn it around. You can just turn around the whole statement if that's helpful to you. It's not required. But that's saying the same thing, isn't it? Do you see that's the same? I just turned the entire thing around, including the symbol in the middle, right? X is still on the wide mouth side. X is greater. X is greater. Both of them are saying the same thing, aren't they? They're both saying X. Whenever you read these statements, you start with X. You don't just go left to right. You start wherever X is. So X is on the right here. X greater than negative 20. X greater than negative 20. Same statement. Same truth. So that means it's what? This C? Right there? Mm-hmm. They also have interval notation. Good on that? Questions on that? Remember all that? Divide by the negative, flip the symbol thing, and get rid of the fraction. Oh, no. Divide by the negative was the other problem. I'm getting confused. Get rid of the fractions problem. Good with that? So I found that people need to review fractions usually a little bit. Practice this. I did it so when you get in your homework, you'll have different numbers. Oh, by the way, it's fine with me if you want to bring your laptops to class or your phones and get some of your homework done during class. Absolutely fine. You can get on the Wi-Fi. I know there's no data. The data's all blocked for most people in here. For my little T-Mobile cheat package, there's no data in here. But you can get on the Wi-Fi. You guys know how to get on the student Wi-Fi? You put in your, what do you do? Put in your student number, and then your password, which originally was first letter of your last, first letter of...
First letter, last name. Capital
first letter, first name, small. Yeah, but you might have changed, if you changed it for Canvas or or Web Advisor, then it's that. It's whatever you now have it. Yeah, so anyway, some people bring their laptops, they get half their homework done during these 2 hours, fine with me. Some would rather just focus and not do that. Whatever works for you, it's fine with me. I'm supposed to even get through part of the next one. I don't know if that's going to happen because I talked too long in the beginning. All right. This is a 3-parter. We call this a compound inequality. It's got 3 sections. Same thing. Basically, whatever you do to one section, you do to all 3. Just follow it right on through. Focus on the x. X is right here saying, I want to be alone. That's the goal, right? To get him alone, to get rid of the stuff that's with x. So how do we get him to be alone? What's the first thing we should do?
Subtract 2 to each side.
Subtract 2 from all 3 of them. And that's gone. And we have 2x. Good so far. Last step to get x alone. X and won't be alone. Divide by 2. And you divide all 3 by 2. And so was it -1 and 2? There we go. Is that good to there? And so the answer is what is it? Is this one B? This one? Yeah. Questions on that one? So whatever you do to one part, you do to all 3. I flash off that. I want to show you. Maybe I'll just show you fast. So -5. 4x minus 6 over 5. Okay. So there we go. So 3-parter. Yeah, fractions. Guys, so what should we do with fractions? What have we talked about with fractions?
Multiply by the denominator.
Multiply by the denominator. Everybody getting the hang of that? So whenever you have fractions, you want to multiply through by the denominator. Multiply through by the denominator to get rid of it. So 5, 5, 5. Good so far. See, that's going to cancel the 1 in the middle. Everybody's kind of seeing how we handle fractions. So whenever we have fractions, we multiply through by the common denominator, in this case, the only denominator. Everybody by that, and that cancels it out. Sometimes I call it the hitman. It takes out denominators. Just saying whatever I can to help you to remember it. Over here it multiplies, doesn't it? And here it's 4x minus 6. And 5 times 0 is just 0 over there, huh? Now it's much easier. No more fractions. So now you just do the normal stuff to get x alone. So we'll just say, all right, add 6 to all 3 there. What's that, minus 19? Yeah. You can use calculators on homework tests, everything, as I said. And last step, divide by 4. So there we go, minus 19/4. This will be x. And 6/4, you've got to reduce that fraction, right? Always reduce fractions. Divide by 2, top and bottom. There we go. And they want the answer in interval notation. That's the parentheses, 2 numbers with a comma, left edge, right edge. So that'll be minus 19/4, 3/2. Parentheses, right, because there's no equals bars. The equal bar means brackets. Bar, bracket, BB. Bar, bracket, no bar, no bracket. Parentheses, right? Good there, we okay? Slow me down if I'm going too fast. It's just, do we have enough time? So x plus 3, x minus 5, greater than x minus 1, x plus 1. Okay. So do you remember foiling and all that? Let's go ahead and FOIL out the left side, FOIL out the right side. And then you're going to end up having x squared on both sides, and you can just subtract the x squared from both sides and just drop it out of there. So you remember foiling, all that stuff, okay? And then you can gather like terms. Minus 5x plus 3x minus 2x. These guys cancel. And then I would just drop the x squared, just subtract x squared from both sides and they're gone, huh? Pretty good to there. If you're rusty on this, I'm glad to do more of this with you in my office hours. And also, we're going to have an assigned tutor. I don't know when he's going to drop. He might drop by in here in a few minutes. Roberto, he'll be at what's called ETC, which means extending the classroom. He'll be regularly visiting and set up special hours to help. So we'll have lots of help available. All right, so how do we get rid of the x? Just subtract x squared from both sides, huh? Like that, boom, boom. Like that. And what do we got? We get to there. All right, and now what do we do to get x alone? We add 15 to both sides. What's that? 14. I'm kind of running out of room here. Minus 2x is greater than 14. And so last step there is to divide by negative 2 and then flip the symbol, huh? Because I divided by a negative. Mm-hmm. So x is less than minus 7. Oh, they want interval notation. I'm looking back here at the blue line. Interval notation. So I got to write x is less than minus 7 in interval notation. And I'm kind of out of room here. So let me come over here maybe. So x is less than minus 7. So if you put that on a number line, it would go like this. It's you don't have to do the number line, but sometimes that helps. So there it is. It's less than minus 7. So that means negative infinity to minus 7, huh? This is the answer they want. Interval notation. You don't have to do that in between number line step. That's not required. I just showed that in case that's helpful. But you can go right from less than negative 7 to that. That's all they want, is the interval notation. Questions on that one? Remember all that stuff from algebra? It's a little review. Okay, so 1/5 less than or equal to x plus 1 over 7 less than 7/8. Okay, fractions again. So what do we do with fractions? Multiply through by the common denominator. We just want to get them out of there, huh? Just multiply through everybody by the common denominator. What is the common denominator? Well, it's whatever those three numbers multiplied together are. So you just 5 times 7 times 8, 40 times 8, 280. So the LCD is going to, common number is going to be 5 times 7 times 8, right? You can do it without a calculator. If you go 5 times 8 is 40, and 7 times 40, 7 times 4 is 28, throw the 0 in the back, 280. So 280 is the, you can just calculate it though. 280 is the common denominator. I just multiplied all those denominators together. 280 is the common denominator. What do I do now with that 280? Top, top, top. Multiply through, right? So 280, 280, 280. Is that good? Then use your calculator. Cross cancel each of those and multiply whatever's left over, right? Cross cancel, multiply the leftovers. So 5 goes into 280, 56 times. You know how you can tell? How can I do that? Because I can do all those numbers in my head? No. I just know 280 is made out of 5 times 7 times 8. So if I take out the 5, I got 7 times 8 left. 56, right? You know, you can just use a calculator, but if you want to do this, take the 7 out of 280. Take the 7 out. Take the 7 out. What's left? 5 times 8. 40. It's got to be 40. Take the 8 out. Take the 8 out. Take the 8 out. What's left? 5 times 7. It's got to go in there 35 times. Like that. So it's just this little tricky if you want. But you use a calculator. All right, so we canceled. Now multiply what's left over. Right? What's left over. Am I going too quick? Questions so far? So I multiplied them all together, found the LCD, top, 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 cross cancel. multiply what's left over. 56 times 1, well, that's just 56. 40 is going to go boom and boom and hit both those. 40x plus 40. And 35 times 7, I have no idea what that 210 and 35, 245, is that right? I think. Let me know if I make a mistake. Good to there. Questions so far? So we cross-canceled and multiplied the leftovers. Right? And now it's easier, huh? No more fractions. Now you can just solve for x a little more regular-like. So solve for x. Here's a, it's a compound inequality, a three-parter. Subtract 40. Like that. So 205. Last step to get x alone. Divide by 40. X. I don't even know. What is 16 over 40?
4 over 10.
So it is, yeah, divide by 4.
2 over 5.
And those would be 4/10. Oh yeah, that's 2/5, huh? 2/5. Just keep reducing it. Here, let's make it 2/5. Yeah, I should have divided top and bottom by 8. That would have been quicker, huh? Just didn't think of it at first. Yeah, 2/5. Just reduce it all the way down. And the other one, I don't look at 205 and 405 and know everything that goes in, but I know at least 5 goes in. That's all I know, right? Because it ends with a 5, ends with a 0. So just start there. I don't know if it goes further than that, but I know 5 goes into both of them. What's that? 41/8. Yeah, I guess that's it, huh? So there we go. Which answer is it? Today? It looks like A to me, doesn't it? 2/5. 41/8, yeah?
Oh,
It's just A.
oh, yeah.
Or is it D? D looks right too. What's wrong with D? A and D both look... Oh, D messed with the parentheses in the wrong way. Yeah, it is A. Anyway, they're just being real picky and all that. Questions on that one? That makes sense. We good? I got a questions I can answer? All right. Yeah. I wish we had a little more time here. So, yeah, absolute value is a little tricky. Wish I had a lot of time, but no. But before I do this particular problem, let me just reason with you about absolute value greater and then absolute value less. In fact, let me just go to a fresh screen. Yeah. So I'll go back to the problem in a minute. Let's just think about what it means to be absolute value
Positive.
less than, say, 10. And then over here, I'll do absolute value greater than, let's say, 4 or whatever. Okay. So all right. And in fact, let's make it less than or equal to. So absolute value x less than or equal to 10. What does that mean?
It only goes down to 0.
So think about, just be real with me for a minute. It's rather than some formula kind of thinking. Just real life. What x's can I put in there that would make that statement true? You know what absolute value does, first off, right? What does absolute value do? Makes it positive, right? They just make things positive. You good with that first off? Seems so simple, doesn't it? You think, makes it positive. That's it. So simple. Such a pain in pre-calc. And when you get to calc, there's some painful things that happen with absolute value. It's surprising because it's so simple. Makes it positive. What's the big deal? Well, some weird stuff happens. So, all right. So it just makes it positive. So real life, what x's could you put in there that would make that true?
0, 1, 2, 3.
Anything 0, 1, yeah, 2, all the way up to 10, right? What else? -1, -2, -3, all the way to -10. Because if you make the absolute value them, then it's positive and it's less than or equal to 10. Anything, in fact, we could summarize that on a number line would probably be the clearest way to see it. To say it's anything from -10 all the way to +10. From here all the way to there. Any number between -10 and +10 put in anything in this region, put in there would make it true. Now anything outside, like negative 11, that wouldn't work. Because negative 11, the absolute value would be positive 11, and that's not less than 10. Or positive 11, put that in, absolute value positive 11 just stays positive, and that's not less than 10. That won't work. But anything between negative 10 and positive 10 is okay, isn't it? Y'all see that? That's true, isn't it? So what does that mean then? That means we have to go like that, don't we? When you remove the absolute value signs. Do you see the logical truth of that? Do you see that? I'm showing you how to faithfully, truly remove the absolute values, right? There's no absolute values here. No absolute value. Right? They're gone. So they're on here, and there they're not. So that's the main, the rest is easy. You can do all the rest, adding, subtracting, all that. You just proved you could do it. We just did a bunch of them. But the crucial step, what I'm really trying to help you understand really clearly, is when you yank off the absolute value signs, what happens? Well, for absolute value less, you got to do this. You got to make a compound inequality. It's just the truth. Okay, now, so, well, here, rather than the now, so summary, so let's just do a summary here. Absolute value of x less than or equal to a number. You remove the removal stage, you remove the absolute value signs, and what do you get? Negative the number, positive the number with the x in the middle. That's what we're saying. That's our general observation, right? When you have absolute value of x less than some number, like less than the 10, you have the negative of that number and the positive number, and the x is between them. That's what that means logically, right? As we saw with the 10. Okay, now let's go over here and think about what it means to be greater. Absolute value greater instead of less. See, this is greater, that was less. Greater than or equal to, whatever. The equals or the not equals, that doesn't matter. That's not a big issue. If they got the bar, they keep the bar all the way. If they don't got the bar, there's no bar all the way. That doesn't matter. But the greater less, that's actually going to be a huge difference. And that's the point people don't get. So let's think about that. We did less. Now, what does it mean logically to say absolute? What could I put in here that would make that true? Well, 4, 5, 6, and on you go. 7, 8, right? Anything 4 or bigger put in there would make it true, right? What else? Yeah, negative 4 or smaller. Right? Would also make that true, wouldn't it? Do you see that? Right? Because if you put in like negative 4 or negative 5, the absolute value will make it positive, and that will be greater than 4, won't it? See how the absolute value does the two, greater does the two outsides, and less does the inside. See, this was inside between the negative 10 and the positive 10. See, it's completely the opposite, isn't it? Absolute value less does the middle between the negative and the positive of that number. And absolute value great does the two outsides from the positive and the negative of the number.
So less into the inside in and greater
So,
inside out.
how many chunks of shading here? 1. How many chunks of shading here? 2. So we need 2 separate statements for absolute value greater. 1 statement in the middle of 2 things for absolute value less. So in other words, here's the rule. Absolute value of x greater than or equal to a number means 2 separate things. It means that the x is less than or equal to the negative number or greater than or equal to the positive number. That's removal.
No, I mean like an upside down U or something.
Yeah, I'm not going to go there. There are other things. So, is that good? There's all kinds of notations, but we're going to go with this one. So, does that make sense there? Everybody see that? So, that's the crucial step on this is getting that idea. You have to get this exactly right. Now, I will let you use a 3x5 card on the exam, so you can write that. I would. This is probably the most important thing to put on the exams. There, how I grade exams, if you just add something wrong, if you're solving a problem, you just add something wrong, I might not even take off anything. I sometimes give full credit even for a wrong answer. It was just adding. I might take off 1 point or give you full credit. But if you turn one of these symbols the wrong way, even though all the rest of your math is perfect, you might get a 0. Because that's really what matters here. So what I'm going for is concepts. I know we all make human mistakes, adding wrong and silly little stuff. I don't care about that. But if you turn just one of those symbols the wrong way, that tells me you don't really get the logic that's happening there. That really matters. So I want to be clear. Students think sometimes that doesn't matter and they just kind of move the numbers around. No, the direction these symbols are going, 2 separate x's, 1 x in the middle, that's the ball game. That's like everything on those. So let's do some now. Let me do that one we were just looking at. We got a couple minutes. I need those minutes. Hold with me. So absolute value of 7x is, what does it say, less than? Less than 28. So on the removal stage, so what I'm going to do is I'm going to yank off those absolute values. So is this an absolute value less or greater? Well, it's a less. So I'm going to, which is the less one? The less one has less statements, so that helps, right? It only has 1 x statement, not the 2 with the or, right? The greater has more, the less has less. So I'm going to put the 28 and the negative 28, and both those are less than. If you look back, see that? That's what I just imitated. All right, and so now how do we solve? And then you know the rest. The rest is cake. Just divide through by 7. But the whole thing is the removal, right? There's no more absolute values here, right? I removed them logically correctly. This you will need in future classes. This keeps on going. So there's the answer. You can put it whatever they want. Interval, they want interval. So -4 to +4. There we go. Okay, let's go on. Let's try another one. If you got that one copied down. I want to do one of the greater than ones. Y'all got that good? And I knew I was talking too long in the beginning. All right, let's try this. Absolute value 5x. So this is greater. Greater. So it's not less. So there's going to be greater. There's going to be 2 statements, aren't they? With an or. That's absolutely crucial. You can't mix these forms. It's either less is 1 triple statement in the middle, and greater is 2 separate with an or. So it's what? Well, the first one, you can keep the first one exactly, well, here. The first one has the -10 less, and the second one is greater. So you're less than the negative. Remember, you're the 2 outsides. You're greater than the positive or less than the negative. That's the removal. That's the other thing. I've noticed students in the past, they'll do this, but then they'll still have the absolute values on there. No, that's an egg. I put a 0 on a problem like that. Because that says to me, they don't understand any of this. They're just monkey see, monkey doing. They don't really logically get what's happening. So it's really important that you understand the concept logically. Do you see what happened? That's the removal. I removed those. And then you just divide by 5. Like that, divide by 5. And there's our answers. They want interval again. So interval on this, guys, is going to be 2 separate intervals. There's 2 separate x's. So there's 2 separate intervals. This would be -infinity to -2 and 2 to infinity. 2 separate intervals. Oh, yeah, they want you to put a u between them. There's the u. You're right. There is a u thing here. They want you to put a u. U just means unite. Unite them together. That's the answer. They'll put a u up there as an option for you. All right, well, that's all the time. We're out of time for today. So a bunch of you need to add, huh? All right, so come on up, and I'll give you an add card for those that need to add.